In this video, we are going to record um, the exercises for using pfSense to mitigate the same DoS attack and compare that with the AS8 mitigations. You're going to download the document here from Canvas, the pfSense IPS DoS mitigation document. And once we download it, you can open it up with Word document. The objective of the lab or to mitigate the same DoS that we have performed from the beginning of the semester using the host-based firewall rule to mitigate it. And now we're going to go through we already went through the ASA V to mitigate the attack last time. And this time we are going to use pfSense to perform the same exercise. The second objective is to make sure that we're familiar with pfSense firewall rules and how do we monitor and troubleshoot the connection problem if we encounter one. And we are going to then compare and contrast what the Cisco ASA and the pfSense, their responses to the same attack are different, and what's the pros and what's the cons. Lab topology is the same as before. 10.01.2, the testing web server victim will be translated to 10.10.10.2, which will be on the outside network, accessible through the pfSense firewall by the attacker 10.10.10.16 and the tester 10.10.10.219. 10.10.10.219 is also going to access 10.10.10.53 to perform a management for the pfSense firewall. The overview is to power on all of those VMs in the topology, and also for both 2016 and 19, we're going to make sure that we can open the web page for the server when we can ping it, and in Windows 2016, we'll then use the OWASP, the tool to attack the web server, and then we're going to record what's the result and compare that with before the attack. And then we're going to configure the rate limit to mitigate the attack and then verify that it does mitigate the attack. And then we also discuss what mitigation did the pfSense perform. And then we will show the open connection per host in the pfSense. And of course, throughout the exercise, we'll save a few screenshots to compare that. Now I'm going to move the document away and start to perform the lab. We have to turn power on for the internet FW if you want to access the internet. And pfSense net, that is our firewall server that's protecting our Meta-E inside. And then 2016 and 2019 will be on the 10.10.10.53, the outside network. So we have to power on all this internet file FW and pfSense net 2016, 2019, and the Meta-E. From the Windows 2016, once we power up, what we want to do is we want to make sure that we can access all the boxes. So we can actually ping 10.10.10.2, the translated address of Meta-E, and we be able to ping 10.10.10.219. So make sure that they all worked. At this point, we can be sure that the image is all up, and then the default image as expected, it's working to communicate with each other. If we do a continuous ping and we take a look at the Meta-E, we wouldn't see any connection because ping is not a connection-oriented TCP. So if you want to test it out, you can actually ping the 2 with a dash T, so it will continuously ping it. And if you go to the Meta-E and you log in, hit enter a few times, and if you do TCP dash TPN, you're not going to see anything because there isn't any connection for it. And I will assume you already know how to sign on to the Meta-E. If not, the document did show you that. We can actually do that, log out. We can just exit one more time. And then MSFADMIN, login, MSFADMIN. And then we can sudo to the super user and it's MSFADMIN, same password. Then, we can actually nest that dash TPM. So you can actually monitor it. And if you want to get out of the monitor screen, you can hold down Control, Alt key together, and let go. And your mouse should be back. If not, just do it a few times, and it should work. Yeah, my mouse is back. Now, according to the handout, we are going to open the web page to see if it works. IE or Edge is easier for refreshing because it pretty much will just go to that page. And you can go to Meta-E to actually quickly take a look at it and see, oh, okay, 219 is already open it again. So 216, we are then going to and we go to 2016 and we actually refresh. And at this point, you can actually go back and take a look at it and say, okay, so 2016 actually established the connection as well. Go back to 2019. Now, we are going to introduce a new monitoring built-in tool of pfSense. So what we will do is we will reduce this and in here, what we will do is we're going to go to 53. So what we're going to do is we're going to sign on to the pfSense. Password is admin, and password is pfSense213. And username is ADMIN. Once you go in, you will take a look at the diagnostics, and we'll take a look at the pf top. And you can see that the 2019 already accessed the 53, 10.10.10.53 to manage that. And we will see the web opening of, oops, okay, take a look at this. In here, 10.10.10.16 actually access 10.01.2 port 80. So this is a monitoring tool that's built into your pfSense. And just a quick review on that firewall. We are going to play with the rules today. And just a review, that net we have to translate one-to-one from the internal one to the external one. And if you click E to edit, you will see external is 10.10.10.2, internal 10.0.1.2. Another one you need to watch out for is the virtual IP. So if we go to edit, you will see that you are serving as a proxy op of 10.10.10.2. So when the outside 10.10.10.16 or .219 accessing 10.10.10.2, our 10.10.10.53 firewall is going to serve as a proxy to answer the request. Now we're ready to launch the attack. So it's already pre-downloaded to the 2016 under download folder, HTTP tools, zip, and we unzip it to extract it all. And once it's extracted, then we go in there and we will run the GUI exe file, and let's run it. And according to the handout, we're going to close this one. It's 10,000, and then that's 1,000 or 4,000, whatever you feel like doing. But it has to be a bigger number, so otherwise it will stop the attack really quick before we even do any further monitoring. So make sure you change the HTTP to the target, and this is how we can run the attack. Now, once we run the attack, you go to the meta-E and you do an up arrow key to see, you're going to see a lot of new connections that's been connected. You can see that it all comes up with a new ID number and just keep constantly adding. So and in your Windows 2019 at this point, in your IE here, we do an F5, and you can see that it's going to just keep running and it will fail and cannot reach the page. In 2016, it's still under attack, and then in your IE here, if we do another F5 to refresh it, then it's going to fail as well. And however, if we want to ping it, it will be still working. Maybe a little bit slower because the resource is being used up. So exit it out of here, and the 2019 will be able to do that as well. Okay, so you see it's not actually working on that. Now let's cancel the attack, and let's go to 2019, and let's take a look at the pfTop diagnostics, pfTop, and let's watch out for the connection. And you can see that, well, there's a lot of from 2016 and connected to port 80. So you can see it's an overwhelming connection to it. So this is similar to the ASAV's show local host or show con, right? Show connection. So this is the equivalence of that. And you will take a screenshot here from this page and also from the meta-E to show the connection, to compare that with the previous screenshot, which is only 1 or 2 connections. Now we are ready to mitigate the attack. And here is the document that we want to go through. Now, we already launched the attack. We already look at the pfTop, and we look at the meta-E. And the ping successful and a web failed because the attack canceled the attack. And now we are going to look at the rules. First thing first, we have to add a new rule. First, to add a permission for TCP access from 10.10.10.219. Go through port 80 and 443, even though for simplicity's sake, we configure the pfSense using port 80 access. It's supposed to use the 443, okay? Just don't want it to get you into too comfortable to click on, yes, I trust the certificate, which is not a good idea because pfSense is a self-signed. That's why choose the port 80 for you to manage it. Anyways, so we are going to click on the firewall rules and then the plus sign in here to add a rule like this. And then we're going to add a second rule. And you can see a tiny A here. That's to add it with advanced feature enable. So that's IPv for TCP. We're going to set that rate limit. And we're going to leave the 2. It's like allow this, allowed it with some provision, and then the rest is permitted. Okay. And in here, this is a screenshot. We're going to select the 219 and allow the HTTP to the HTTPS. and IPv4 with TCP. And we're going to add a second one. The second one, we are going to actually click on the firewall rule, add it. And then once we add it, we're going to add advanced. So you click advanced, we're going to put the rate limit in here, the control. So it will be 10, 10, and 10 and 5. Okay, 10, 10, 10, and 5 here. Now, it's very important to make sure that the first firewall rule to permit this one is on the top, and the rate limit is on second, similar to the screenshot specified here. Okay, I'm going to move the document on the side and go to 2019 and add the rule. So we're going to go to the firewall, and then we're going to the rules. And now we're going to add a rule. So you're going to click on the plus sign here, and pass, it's okay. It's a one rule. IPv4 is fine. And we're going to do TCP and source from a host. We don't want any one single host, and we can put in 10.10.10.219. And the port, we can get HTTP, and well, you can just do one port, or you can open in between. We don't need to log it. There's nothing else we need to do, so we can save it. We don't have to apply the change right away, so we saw it in here, or you can apply the change first. And we're going to add another rule. It's a TCP again. This time it's any. Destination is any. Okay. And we are going to go to advanced option here. So we're going to click advanced option and go to the maximum connection. It's 10 and 10 and 10, and we'll give it just 5 per second. You can of course increase that limit. Now, if you apply the change now, you will see that your 219 is after the rule. So if we apply that, when we try to refresh, we will lock ourselves out because you will be blocked here. You will trigger and put you into the virus vault, which is in here. If you go to diagnostic, go to the table, and you will take a look at this virus virus probe, then you will see that you got blocked out. The way to mitigate that or to resolve the problem, not mitigate, if we accidentally kick ourselves out, you'll go here and you go to number 8 and go to the shell. Go to number 8 and you can say pfCTL-D to disable it, or CTL-E to enable it. If you disable it from here, then of course, if we lock ourselves out, it doesn't matter. It will still allow us to go back in and fix the problem here and remove ourselves from being blocked. So we are going to have to move this one up. So we're going to select this rule, and then so we're going to select the rule that we want to move up. So select the rule, and then go to the first rule and say move the selected rule before the rule. So you just click that, then we'll move the 219 on top, okay? And then we can apply the change. So when we hit, it's going to hit the first line, so it will not be blocked accidentally. So our rule will look like this. First, permit ourselves in, and then implement the rate limit like this one. So now we're going to do our final test, launching the attack again, and then verify that and take copy of the screenshot for the result. We're going to 2016. Of course, it cannot be displayed again. We replaced F5, I just did, and of course it worked because we haven't launched the attack yet. The attack's here. And go to the 2019, and now it should work because we didn't actually do an F5 here, because we didn't actually perform the attack now, right? So now, after we implement the rate limit and we launch the attack, it should still work. Okay, so let's take a look at that again. Go to the Meta-E just to verify. And we'll take a look at that. And you can see that 16 and 2019, they did finish that already. It's a finishing waiting, right? The FinAct is waiting. It's already past the establishment stage. So we can launch attack again now. So we go to the Windows 2016 to launch the attack. So we run the attack again. And you can see that it got fixed into 6 of the maximum connection in here. So we can actually refresh, and the attacker, it will have a problem because you already been blocked. You already reached your maximum. And the regular user here, if you do an F5, it will work. Do another F5, and then we can verify that going to here and take a look at it. And you can see that your 2019 actually be able to, and your 2016 will have some problem because it already been blocked. Let's take a look at the reason why in here. We can actually cancel the attack now. See, the connection is 0 now before we do that, because it's already timeout. That's why you don't see Windows 2016, the original file connection showing up in the Meta-E, because before I stop the attack, it's already been cleared up. So let's say okay on that. And when you run the attack again, it's going to be 0. The reason is this is quite different than the ASAV, because the pfSense actually in here, once you violated that rule, it's going to set it into under the tables, under the virus probe in here. You see the attacker has been blocked. So we can actually eliminate it, all right? And then from there, Meta-E, we can take a look at it again. Click here. So you will see one of each. 2016 got one connection on that. 2019. So let's take a look at 2016. Let's launch the attack. Once you run the attack, you can see I got 5. And let's go to Meta-E and take a look at it. Now you can see they do have 6 of those connections in there. And now we go to, and it can max out. So we go to 2019, and we will come here and F5 and go back to Meta-E. And you will be able to see that 2019 now is in there. Got a connection inside. And again, after a while, 2016 will be 0 out because it's been actively blocked by the pfSense in here. Do an F5 to refresh it, it's already got blocked again. So then the connection, once it's timeout, they do not have anything, do not have any rights to go back in again. And when you try to ping, it definitely will fail. All of them will fail from 2016. So we have mitigated, and then we run the same test, and you will see that it shows five. Actually, it shows 6 connections passing through instead of five. I believe we set up as 5, but sometimes you got one sneak in on the first one, it doesn't count it. We can actually look into that. And also there is a PF top showing. We're going to look at the PF top in here and see what's going on. Go to 2019. And we'll go to the diagnostics, and we'll go to the PF top. And you can see that 2016, they have those attempt still under attack, I guess. So let me stop it. Control C, so it will not keep showing up in there. Okay. So first, let's summarize it with the difference. That's the main point I want to make, is when you go into the table and you take a look at the virus prop, then you see that it got actively blocked. So then what is the important implication of that? ASA, it will not actively block that. It will just set a limit to 5 of them and just stay at 5. And pfSense, it not only sets a limit, but it will block that. That raises one of the potential issues, that if we blocked it and if the attacker forging the IP addresses to something else, and then we might DoS ourselves. So that's one of the very important consideration. Depends on our company policy and then how comprehensive we want to make our do not block list goes. So different operating system, different IPS, different firewall, they have different reactions. And we can always dig into the detail to modify it to what our needs, but we have to pay attention to what the consequences and the results. And that's the end of this lab. Oh, by the way, one extra thing, looking into the mitigations, we have set up 5 maximum per second for the connection in our rate limit on the firewall rule. In here, take a look at our firewall rules. Yeah, this is the rule that we want to look at. That's one with advanced settings. Go in there, take a look, and then roll it down a little, and you can see that we set up 5 maximum connections. And then if we take a look at the meta-E in here, we have 1, 2, 3, 4, 5, 6. And you can see in sequence 255, 25, pretty much 256, 57, 58, 59, and then it jump a little. Total 6. It's allowing 5 per second. So once the 6th one hits, the connected pfSense has a tendency for letting one packet going through when they're triggering the rule. So that's why you see 6 instead of 5 connections from the attacker 2016. And then you got one connection from 2019. That's a regular request. Okay. That ends the discussion and this exercise.